Question 60. Base your answers to questions 60 through 62 on the diagram below, which shows the relative diameter sizes of the planets compared to the radius of the Sun. Question 60. Base your answers to questions 62 through 62 on the diagram below, which shows the relative diameter sizes of the planets compared to the Sun. So, they show you, let's say this is the center of the Sun to the Sun's radius, and that means this is a slice of the Sun, starting from where it says center of radius, that's the middle of the Sun. The radius starts at the middle of a circle and goes to the end of the circle. 2 radiuses is equal to 1 diameter. So here's the center of the Sun. This is the Sun's radius from here to here. Now, inside the Sun you have Jupiter, Saturn, Uranus, Neptune, Mars, Earth, Venus, and Mercury. And they say this is around their sizes compared to the Sun. Now, the question is, on question 60, on the diagram, circle only the terrestrial planets. Well, what are terrestrial planets? Terrestrial planets are composed mostly of metal silicates and are small, dense, and rocky. Well, that's Mars, Earth, Venus, and Mercury. So we'll circle those. That's the answer to question 60. Again, question 60, on the diagram, circle only the terrestrial planets. So terrestrial planets we know are composed mostly of metal silicates and are small, dense, and rocky. So those are Mars, Earth, Venus, and Mercury. Question 62. Place an X on the planet with the lowest density. Well, first of all, we told you what terrestrial planets are. In question 61, we told you that terrestrial planets are composed mostly of metal silicates and are small, dense, and rocky. So now we want to know a planet with the lowest density. So that's one of the Jovian planets, because the Jovian planets are large, low density, and gaseous, made mainly of hydrogen and helium. So from these large planets with low density, which one has the lowest density? The answer is Saturn. So I put an X on Saturn. So the answer to question 61, make an X in the middle of Saturn. Question 62. How many times larger is the diameter of the Sun than the diameter of Jupiter? Well, you'll have to look at your chart of solar system data. Over there you have an object. You have a lot of other things over there also. Beforehand, in the last question, in density, in question 61, it asked which planet was the least dense. It's also in the solar system data, you'll find it. So you look down over here, I just put in Saturn to show you that the density of Saturn is 0.7, and you'll see all the other numbers, so the other planets are higher, so Saturn has the least density. So, for question 62, how many times larger is the diameter of the Sun than the diameter of Jupiter? So look at the solar system data. So I just put in what we need, which is the object, the equilateral diameter. Density we don't need, so I'm going to take that out for now. It's just going to mix you up. So we see that the Sun's diameter is 1,392,000 kilometers. Jupiter's diameter is 142,800 kilometers. So if you do that, you do 142,000. If you do 1 million, if you do 1,392,000, which is the diameter of the Sun, divided by the diameter of Jupiter, because it says how many times bigger is the diameter of the Sun than the diameter of Jupiter. That means you're going to take the diameter of the Sun and divide it by the diameter of Jupiter to tell us how many diameters of Jupiter can you fit in the diameter of the Sun. So the diameter of the Sun is 1,392,000 divided by the diameter of Jupiter, which is 142,800. That gives us 9.74. So 9.74 with a long number at the end. But they want just in the tenths place. They don't want they don't want the 4, which is in the hundredths place, or the 7, which is in the thousandths place, or the 8, which is in the 10,000th place. They just want the basic number over here. So the answer, they allow you to give an answer of 9.5. That means 9.5 diameters of Jupiter can fit in the sun, in the diameter of the sun. And they allow you to go up to 11.5. That means 9.5, 9.6, 9.11, 9.9, 10.7, 11.3 till 11.5 you'll get right. How come they give you so much space? The reason is because if you look at different charts, they'll give you different information about the diameter of Jupiter. In the solar system data that we have, it tells you that the diameter of Jupiter is 142,800. And if you divide that into the sun, you get about 9.7. And what they give you, let's say, in some other books, like I saw in the Red Baron's book, they say that the diameter of Jupiter is 142,984. So that's a different number. But that's also, you'll write down 9.7, because if you divide it, will be 9.73. And the first one that we have in our data chart is 9.74. It's still going to be the same 9.7. However, I looked up one thing and I saw that there's another place that says that the radius, another chart that shows that the radius of Jupiter is 68,700. Now the radius is half the diameter. So multiplying the radius by 2, you'll have the diameter. 68,700 times 2 is 137,400. Divide the diameter of the sun by 137,400. You'll get 10.13. That means you'll get 10.1. So that's why they allow you to go up till 11.5. So if you give an answer from the answer that you should give according to what you have on your data chart should be this answer over here, which is 9.74789916. But they don't want that. All they want is the 9.7. What you should do is, the answer is 9.7. 9.7. And you circle that answer. However, you can write, if you would have written, and you would have written 9.5, you would have gotten it right. If you would have written the answer you got over here, which is 10.1, you also would have gotten it right. Make sure they could see that point. Because if they can't see the decimal, they're going to give it to you wrong. It will look like 101. So anything between, we're going to erase this for now. You will get 9.7 as your answer if you go according to the solar system data that you have in your charts. But if you do 9.5 till 11.5, you will get that answer right. But don't put that answer in. You have to give an exact answer. And the exact answer you will get from the solar system data is 9.7. So the answer to question 62 is 9.7. But if you would have used some other data system, you would have used some other chart, not the ones you get on the Regent, you would have gotten somewhere between 9.5 and 11.5. The reason why I brought down the thing that I saw one chart with this radius, which makes the diameter of Jupiter 137,400, is to show you that with the solar system data it's 9.7. And you'll see that people will tell you that you could write down 9.5 to 11.5. You won't understand why. The answer is because if you take the diameter of the sun, which is 1,392,000, and divide it by the other chart I saw, which gives the radius, and you multiply that to get the diameter, then you take the sun's diameter and divide it by that, you'll get 10.1. So that's why they allow you to do 9.5, 9.6, 9.7, till a number. If you do below 9.5, or if you give a number above 11.5, you'll get it wrong. However, from all the charts, you shouldn't get any number lower than 9.5 or higher than 11.5. And over here, you follow the charts in the course on the regions, you'll see that the answer is 9.7.